9g, differentiation of e to the power of x. Now for differentiating e to the power of x, there is a very specific rule, and it doesn't really look very different, and that's because that when you differentiate the function e to the power of x, you get exactly the same function, e to the power of x. So nothing happens, the derivative is equal to the initial function. It does change a little bit when we have a different function in the power. So say this time we have the function k of x. The way I can figure out how this will work is to go ahead and use my chain rule. The way that I can figure out how I can differentiate when I have another function as a power is to use my chain rule. So if we rewrite this as y equals e to the power of u, where u is equal to our function k of x, we can go ahead and use the chain rule to understand the way that this works. So from the chain rule, we know that dy by du is equal to the derivative of e to the power of u, which in this case we know is exactly the same, according to this rule, that the derivative is the same as the power. We also need to differentiate our inside function, so that will just equal k. And we know that our final derivative, dy by dx, is equal to the outside function, e to the power of u, times the inside function, which is k. So when I replace u with its original function, what I will get is e to the power of kx times k, which is equal to ke to the power of kx. So what you can see in this specific case is that all I've simply done is pulled out the gradient of my inside function and multiplied that by my original function there. So what we could say in general is that if we have a function f of x is equal to e to the power of g of x, so g of x is my power, the derivative is the derivative of that power function, the inside function, multiplied by my original function. Let's practice some of these now. So example 13, differentiate each of the following expressions. So my inside function here, which is 2x, the derivative of that, so du by dx, is equal to 2. So all I simply need to do is multiply my function by 2 because that is the derivative. 3 remains as that's just a constant. And then this function here, e, remains as e to the power of 2x because e to the power of x doesn't get affected. The only reason we have this 2 out the front is because that is the derivative of the inside function. So that will be 6e to the power of 2x. Same thing here. In this case, for part B, our inside function is 2x plus 3. Remembering that this function remains as it is because it is a function of e. So all I have to do is multiply this function by the derivative. So the derivative in this case is negative 2. So f dash of x will equal the derivative of the inside multiplied by the function itself. Now we have learned that the chain rule is the derivative of the inside times the derivative of the outside, but the derivative of the outside doesn't change. Our e function remains as it is. So that's why it looks like there is no change to the inside function. Again, this time what we have is several functions. What I'm going to start doing is speed up this little process, but rather than writing u equals for each one, I'm just going to start multiplying it by the derivative. So here, my original function, 3e2x remains, and what I need to multiply that with is the derivative function. The derivative of 2x is just 2. The derivative of negative x is negative 1. And finally, the derivative of negative 2x is negative 2. So that's minus, so this minus here, and then minus 2 times 4e to the power of negative 2x. Now I can put these all together. 2 times 3 is 6 e to the 2x. That will be minus 2 to the power of e to the negative x. And then a minus makes a positive. 2 times 4 is 8. And that will be my final answer. You can also express this with positive powers. Part D. Again, this inside function, I just need to find the derivative of it. It may look a little confusing, so I will write it out this time. Instead of writing x on 4, just to make it a little bit clearer, that is a quarter x. And so the derivative is just simply negative 1/4. So again, the derivative of this will be equal to the the derivative of the inside, which is negative a quarter, and that will be multiplied by the derivative of the outside, which doesn't actually change. So I will keep the 2 as that's just a constant, and then that is the derivative of the outside function there. 2 times a quarter is a negative half e to x on 4. Once again, my inside function, the derivative will be 2x minus 2, and therefore the derivative of my whole function will be the derivative of the inside function, which is just going to be 2x minus 2. This time make sure you use brackets because there's more than one term, multiplied by the outside function. I would probably leave it like this so that I don't end up with too many e's everywhere. I've just rewritten it so it's in one single color. Part F, once again, recognizing that this is the inside function. Deriving this function. Now, this is going to be a little confusing because it's going to feel like a chain rule within a chain rule. So in order to derive this rule, I do need to use the chain rule. So that's where the 2 is going to come out the front. And then I need to multiply that by the derivative of its inside function, which is this one over here. Now, all of this is going to be multiplied by the function as it is, which is technically the derivative function, but it's going to look the same because it is an e function. So that's the derivative of the inside, and then multiplied by the derivative of the outside.